Okay, so hi everyone, Senan this side, and in this video we are going to see how to find a cycle in an undirected graph, but this time using breadth first search, not depth first search. That was my last video, but let's see how do we do that. The logic would be I would go in the breadth first manner in this whole graph. First I'll go to 0, then I would go to 1, then I would go to 2 and 4, and then I would go to 3. That is the way that I'm going to proceed, but at the same time I need to track of my parent node as well, right? From which node did I come to 4? To get to 4 I got here from 1, get to 1 I got here from 0. So somewhere down the line when you get a call for 3 from 2, you would mark 3 as visited, and you would say that the parent of 3 is 2. But when you go for 4 and you check for 3 again, you would see the parent of 3 would be 2 and not 4. So that means you found at least 2 ways to reach this node number 3. So that is how we are going to detect a cycle. The logic is totally same as we did it in DFS. So I just, in the last video, this was DFS, and in this I'll just change this to BFS. Now let's look at the BFS function. So it takes the node, it takes the visited array and the adjacency list. Now since a breadth first search uses queue data structure, I would take this queue and I would push this node, and since this node has no parents, I would initialize this to -1. Otherwise what I would do is, and I would do this, is mark this visited as 1. Now I would go into this while loop, but before that know that this queue is basically a pair of integers. And why? So this keeps track of the current node in the first position and the parent in the second position. Okay, so in the while loop you get the topmost element using queue.front, then you remove that from the queue and you just store the current node and its parent into two separate integers. Now what I do is, given this node, I find all the neighbors of this node, and if I see if it is visited, right, if I have not visited this element, I would mark this as visited and I would push that as a part of my queue. Otherwise what I would do is, if this element that I am seeing right now is visited, then and only then I would come to this else if statement, and that is not equal to parent. When we go from parent to the child, parent would be marked as visited. So if element is not the parent, that means I must have found some other way to reach this node lm through a different node, and again I'm reaching the same element. Then that must be the case when you have two different paths starting from the same node. You had two different paths reaching this node lm. That means there was a cycle somewhere in between, and in that case I would return true, otherwise I would return false. And I've used this for loop in this is cycle because the graph could be disconnected. So that was the whole video about. Not much to explain because the main explanation was done in the previous video when we did this from DFS. For DFS you could just, if you want the iterative way for DFS, you can just change this to stack, and this front would be top, and otherwise almost everything would be the same. Okay, so if you look at the time and space complexity, it would be same as this space complexity, because at max you can store all the elements in this stack basically. And since storing a pair of v elements is the worst case, so the space complexity could be 2 times v, which is big O of v. And while we are going through this, we are going to see every edge twice. We may or we may not perform these actions, but that is a constant time operation. But we are going to through every edge twice. Why? Because for 3 I would check for 2, and for 2 I would check 3 as well. So this node is considered twice, so the time complexity would be big O of v plus 2 times of e. Okay, so hope this was clear, and thanks for watching.